You know, in the world of open source AI, it feels like a handful of giants are always calling the shots. But today, we're going to dig into the story of a small American startup that made a huge, gutsy bet to try and change all that.
So let me ask you a question. If you had to guess who's been crushing it in the high-performance open-source AI game lately, who would you pick? Well, for the past year, the answer has been surprisingly clear, and it really points to one part of the world.
And this number really sets the stage for everything. For the last year, a whopping 90% of the best-performing open-source models have come out of China. I mean, that's not just leading, that is near total dominance by a few incredibly powerful players.
Now, here's where it gets really interesting, because this isn't just about bragging rights or who has the best tech. This dominance has created a huge business problem. American companies are getting, pretty nervous about building their entire businesses on top of models from other countries. They're worried about compliance, data privacy, the stability of their AI supply chain, you name it. And that created a major gap in the market.
And stepping right into that gap is a small startup called Acri AI. They looked at this whole situation not as a threat, but as a massive opportunity, a chance to build something new, something powerful, right here in the US. So to really get how bold this was, you gotta know where they came from. Acri AI, they weren't originally building these huge foundational models. Their business was taking existing open models and tweaking them, fine-tuning them for clients. It's a good business, for sure, but they realized they couldn't keep depending on other people's work. They needed to control the entire stack.
And this is where they just went all in. I mean, they took 70% of their own company's money, put a pause on the work that was actually bringing in revenue, and for 6 straight months, they put every single resource they had into one giant goal, training their own large-scale model completely from scratch.
And the speed they moved at was it was unbelievable. They kicked things off in July 2025 with a pretty small model, just to kind of test the waters. Then they built these nano and mini versions to really master a super complex training technique. And then, bam, by January, just 6 months later, they shipped the massive 400 billion parameter Trinity Large. What a sprint.
So you're probably wondering, how on earth does a small team with just a fraction of the resources even begin to compete with these huge state-backed labs? Well, they didn't try to outspend them or outcompute them. They got clever. They focused on one key advantage, something called extreme sparsity.
The secret sauce here is a technology called mixture of experts, or MoE for short. Okay, so instead of one giant clunky brain trying to do everything, an MoE model is made up of lots of smaller, specialized expert networks. And the real key is, for any problem you give it, it only wakes up the few experts that are perfect for that job. Here's an easy way to picture it. Imagine you have a really specific legal question. You wouldn't call up every single lawyer in the country to get an answer, right? No way. You'd go to a small team of specialists who know that one area inside and out. That's exactly what an MLE model does. It's targeted, it's efficient.
And that brings us to a really critical idea, the difference between total parameters and active parameters. Total parameters are like all the books in a gigantic library, all the knowledge the model could possibly use. But the active parameters? Those are just the specific books you actually pull off the shelf for a single research project. It's the only part you're actually using in that moment. And check this out. Here's how that plays out with Trinity Large. The model has this massive library of almost 400 billion total parameters. Huge. But for any single task, it only activates about 13 billion of them. So it has the wisdom of a giant, but it moves with the speed of a much, much smaller model. What you're looking at right here is the result of that cleverness, extreme sparsity. That tiny little sliver, just 1.56%, represents the active part of the model. The rest is just waiting in the wings. This incredible efficiency, that is Trinity's secret weapon. It's how they can punch way above their weight class. Okay, so the architecture is smart, it's clever, but does it actually work? I mean, Critchy's huge bet would only pay off if the model could deliver on 3 big promises. It had to be competitive, it had to be faster, and at the end of the day, it had to be cheaper to run.
All right, first up, how good is it? Well, on the AMI 2025 benchmark, which is a tough test of advanced reasoning, Trinity Large doesn't just keep up, it scores well ahead of major players like Llama 4 Maverick. So right away, that proves they didn't have to sacrifice quality to get all that efficiency.
Now this chart, This is where you really see the payoff from all that sparsity. When you run it on the exact same hardware, side by side, Trinity Large is about 2 to 3 times faster than its main competitors. And that's not a small difference. That is a game-changing leap in speed.
So why does all that speed matter so much? Honestly, it all comes down to simple economics. For the companies that Acri is trying to sell to, faster performance directly translates to cheaper operating costs, period. So it's not just a cool piece of tech, it's a really compelling business case.
Okay, so let's zoom out for a second. Beyond all the tech specs and the benchmarks, why is a model like Trinity Large such a big deal for the AI world as a whole? What's the real story here?
When you boil it all down, Trinity Large matters because it's American-made, trained right here in the U.S. on U.S. infrastructure, which gives companies total transparency. It's also fully open for commercial use. It plugs that huge gap in the market for a powerful, homegrown, open-source model. And that addresses all those enterprise fears about compliance and reduces our reliance on a global supply chain for something so critical.
You know, the story of Acri AI is just a fantastic example of what can happen with smart risk-taking and real innovation. They spotted a problem, they literally bet the company on a solution, and they actually delivered a model that's not only competitive, but perfectly positioned for the market. And it leaves us with this one big question. Is this just a cool one-off success story, or are we maybe seeing the start of a real American comeback in the open-source AI race?